So before we get started, there are two things I'd like to mention. The first is that all the slides, the speakers notes, and the demos are available for download, and I will be providing a link at the end of the talk. I tend to be one of those folks who can't keep up with the speaker and take notes at the same time. So for those folks in the same situation, there's no need to take notes. Everything I'm covering, absolutely everything, is going to be available for download. The second is to please hold all questions until the end. If you have questions, please make a note of them and ask me afterwards. With luck, I'll be able to answer most of your questions during the talk itself. So, in the beginning, which for this discussion is 1984, there was the Macintosh file system. So this file system was introduced with the original Apple Macintosh computer in January 1984, and it's designed to store files on 400 kilobyte floppy disks. So MFS had a number of features that would be familiar to later Macintosh users. The first is that it introduced resource forks as a way to accomplish the following. It allowed graphical data to be stored on disk until it was needed, and that allowed the OS to retrieve that data into memory, draw it on the screen, and then discard it from memory. They allowed easier translation of applications for a foreign market. So an application's pictures and text were stored in the resource fork, so only that resource fork needed to be edited in order to make an application available for a different language or nation. And the third thing was that resource forks also allowed the distribution of all, or almost all, of the components of an application inside of a single file. And this simplified application installation and removal. And of course, the other thing that MFS introduced was storing the metadata needed to support the graphical user interface of the Mac's operating system, and that was starting with System 1 in 1984. So one feature that was different from how Mac file systems work today is that MFS did not support the concept of a hierarchy of directories. Instead, MFS was actually a flat file system where all the files were stored at the same level. So folders existed as a concept in MFS, but they work completely differently than they would do in modern file systems. So the Finder created the illusion of folders that were visible in the Finder, but then when you went to look for them in the save and open dialog boxes of applications, you couldn't find them. So there was always a folder called empty folder, which could be used to create new folders in the Finder by altering that existing empty folder. And as folders were altered by adding files to them or by renaming the directory, a new empty folder would then appear. So in reality, what the file system was doing was it was storing all files using a directory and file handle pairing. So when it was asked to display the contents of a particular folder, MFS would scan the directory for all files that matched that particular directory handle pairing, and then it would display the contents of that search. So let's take a look at how this worked back in the day. So we've got a drive here called data. Empty folder here, and just to show you how this gets recreated, I'm going to toss this in the trash, and then I'm going to throw away the trash. Bulging trash can was still in the future. So we're going to close out, but we need to restart Finder in order for this to work. So what we're going to do is we're going to go onto the boot disk, we're going to launch teach text, which will automatically quit Finder. Then we're going to go ahead and quit out of teach text. Memories, huh? We're going to go ahead and close out the system disk. Now if we go back to the data drive, there's empty folder back again. So this is how it worked on Macintosh file system. So MFS had the following limitations. A maximum volume size was 20 megabytes. Megabytes are close to, but not exactly megabytes. Maximum file size was also 20 megabytes. Maximum number of files was an enormous 4,094. Maximum file name length was 255, although the Finder imposed its own limitation of 63 characters. So MFS was discontinued as the Mac's primary file system by Apple in September 1985. This marks it as Apple's shortest-lived file system for the Mac. So reading and writing to MFS volumes continued to be supported up until System 761, when Apple dropped support for writing to MFS volumes. All support for MFS was dropped in macOS 8.0, and the file system was never natively supported on OS X and later. Now that said, one of Apple's provided example file system plugins for OS X is named MFS Lives, and it provides read-only support for MFS volumes. So for those of you out there with that one really old floppy, there's hope. So to replace MFS, Apple introduced the Hierarchical File System, otherwise known as HFS, in September 1985. And this was a case of hardware needs driving software design, because HFS was introduced to support the Hard Disk 20, which was Apple's first hard disk drive for the Macintosh. So the reason for the change is that MFS had been optimized for use on very small and slow media, namely floppy disks. So in contrast, the hard disk 20 contained an enormous 20 megabyte hard drive, which provided over 50 times the data storage of the stock 400 kilobyte drive. So the introduction of larger media like Apple's hard disk 20 exposed a scaling issue in MFS that needed to be addressed. So MFS's method of displaying files in a folder by searching for directory and file handle pairing, that worked fine when you were dealing with a few hundred kilobytes of storage and maybe up to 100 files. But now you were dealing with megabytes of storage and thousands of files, and this search method proved to be very inefficient and it had a noticeable performance impact as well. So Apple's solution to the problem was to replace MFS's flat file structure with a directory-based file system that leveraged a new file known as the catalog file. The catalog file incorporated a binary search tree structure, this is also known as a B tree, which could be searched quickly regardless of the size of the storage volume. So HFS incorporated a number of features that were first introduced in MFS, including the use of resource forks and having a maximum file name length of 255 characters, although the Finder, curiously enough, imposed a further limitation and did not allow more than 31 characters to be used. This wasn't a file system limitation, this was a Finder limitation that you could only use 31 characters. So HFS also introduced some new folders, including actual directories stored in a hierarchy. So files were also now referenced by the file system using unique file identifiers, rather than by using a file extension like on Windows, and that allowed files to be named almost anything without losing track of what application was supposed to be able to open them. And the designers of HFS also redeveloped various file system structures in order to be able to handle larger numbers, with most of them being upgraded from using MFS's 16-bit integers to now using 32-bit. Now that said, one place where upsizing did not take place was in the number of files supported, and that remained a 16-bit integer, with HFS being able to support up to 65,535 files, and this becomes important later. So, let's take a look at how this works on MFS. I'm creating a bunch of directories, nesting them all within each other. As you can see, we actually do have directories here, and I'm now going to pull in a file at the very bottom, and pull up get info. And as you can see from where, we do have this, we now have this firm concept of the hierarchy of directory, but also thanks to the B tree, it found it very quickly. So HFS had the following limitations. Maximum volume size was 2 terabytes. Not that any of us had a 2 terabyte drive back in the HFS days. Maximum file size was 2 gigabytes. Maximum number of files, as mentioned before, was 65,535. Maximum file name length was 255, although the Finder, as mentioned previously, did not allow more than 31 characters to be used. So, along with solving MFS's issues, HFS had a few of its own. So the catalog file, which was the replacement for MFS's directory file handle pairing, stores all the files and directory records into a single data structure. So this can result in performance problems with multitasking because only one program at a time can write to the structure. So if an application is hogging the system, other programs are now having to wait their turn to write their data to the catalog file. Damage to the catalog file can also result in catastrophic file system damage, because the catalog file's role is that of being the only place where all these file and directory records are stored. So if this goes down, everything goes down. And another issue with HFS had to do with block allocation. So a storage volume is inherently divided into logical blocks of 512 bytes. HFS groups these logical blocks into allocation blocks, which can contain one or more logical blocks depending on the total size of the volume. So HFS uses a 16-bit value to address these allocation blocks, and that limits the number of allocation blocks to 65,535. So HFS could support a maximum of 65,535 files, with each file being assigned at least one allocation block on the file system. And this was regardless of the size of that storage volume. So this maximum limit also introduced a minimum file size limit as a logical consequence, because now any file could not be smaller than one allocation block or 165,535th of the size of the drive. So when your available drives were well under 1 gigabyte in size, this really wasn't a big problem, but as drives got larger, the smallest amount of space that any one file could occupy became excessively large. So to illustrate the issue, let's take a look at how HFS is operating on a 1 gigabyte disk. So 1 gigabyte divided by 65,535 is in the neighborhood of about 16 kilobytes, and as you can tell, the OS even rounds that up a little to 17 kilobytes. So this meant that the minimum file size of any file on a 1 gigabyte drive formatted with HFS was effectively 16 kilobytes, and that was regardless of the file's actual size. So even a 1 byte file would take up a dead minimum of 16 kilobytes of space. So with users with a lot of small files, a lot of disk space could be lost to this minimum file size limitation. So for what it's worth, Apple is not the only one who designed a file system like this. The FAT16 file system used on DOS and earlier versions of Windows has exactly the same issue. So to fix this storage allocation issue and to add other improvements, Apple introduced another file system in 1998. So HFS Plus was introduced with macOS 8.1 in 1998, and it was designed, among other things, to fix this block allocation issue in HFS. So this was accomplished by upgrading block allocation to use 32-bit integers in place of HFS's 16-bit, and that allowed for a much lower minimum file size. We still have it today, but it's much lower, it's much more manageable. So along with the block allocation issue, there were a number of other issues that got addressed as part of creating HFS Plus. So those changes included implementing Unicode support, and also addressing the issue of long file names, so you can now actually use 255 characters in a file name. And over the years, Apple has added new features to HFS Plus to accommodate new needs. So starting in macOS 10.2.2, optional journaling features were added. So this journal keeps track of changes not yet committed to the catalog file by recording the intentions of such change in a logging mechanism. So in the event of a system crash or power failure, this continuous logging process allows HFS Plus volumes to be brought back online much more quickly with much lower likelihood of becoming corrupted. So in 10.3, all HFS Plus volumes are now set to use this journaling by default. HFS X support was added to enable the creation of case-sensitive HFS Plus volumes. There were a number of applications that didn't deal with that well. So by default, we're still using case-insensitive HFS Plus volumes, but the support for case sensitivity has been in there since 10.3. Also, Unicode 3.2 support was added. As of 10.4, support was added for Windows-style access control list file security. So this is in addition to the existing support for standard Unix permissions. Also, support was added for arbitrarily extensible file system metadata. This is otherwise known as extended attributes. This was a replacement for the original macOS resource fork file structure, although, of course, HFS Plus still natively supports resource forks. So in 10.5, Unix hard linking support is added to support Time Machine. 10.6, HFS Plus compression is added to provide a transparent way to reduce disk space usage and also to reduce disk I/O. 10.7, core storage logical volume management is added to provide support for File Vault 2's logical volume encryption. In 10.8, Apple took core storage and extended it to provide multiple device management, which is how we wound up with Apple's Fusion drives. And off the Mac platform, on iOS, tvOS, and watchOS, support was added for per-file encryption. Now, this was not brought back to the Macs. We have File Vault 2 in its place. But the other Mac devices are also using HFS Plus currently, and for them, this support was added for this per-file encryption. So HFS Plus first shipped in 1998. That was 19 years ago. Since that time, file systems on other platforms have shipped that include features that are not currently present in HFS Plus. So one has to do with data checksumming. HFS Plus does not include the ability to checksum metadata, and that helps to detect file system corruption on other file systems. Nanosecond timestamping. HFS Plus has 1 second timestamp granularity, which means that reads and writes to the file system can be tracked down to the second. Being able to track with nanosecond timestamp granularity helps prevent file writing updates from occurring only partially, because that can be worse sometimes than to have a partial write to the file system than not have that write happen at all. Also, concurrent access to the file system, as this is an issue that carried over from HFS. HFS Plus is a single-threaded file system, which means that only one process can update the file system at any one time. So if an application is hogging the system, other programs are waiting their turn to write their data, and this particular issue may be most easily visible during Time Machine backups when you get that lovely spinning beach ball. So other limitations include date limitations. HFS Plus stores date in 32-bit integers containing the number of seconds since midnight, January 1st, 1904, Greenwich Mean Time. The consequence is that HFS Plus's maximum representable date is February 6, 2040 at 6:28 in the morning and 15 seconds Greenwich Mean Time. I'm sure back in 1998 this didn't seem like a big issue. We're now here in 2017. The issue's a bit more immediate. We should probably fix this now. Sparse file support. HFS Plus does not support sparse files, which are a type of computer file that attempt to use file space more efficiently by writing reference metadata for the empty space found in files. So instead of just going, I know this is empty space, I'm just going to write a tag here to represent it and not take up the space in the file system, HFS Plus will instead just write a bunch of zeros to represent the empty space, which takes up actual space in your file system. Snapshot support. HFS Plus does not support capturing file system snapshots, which means creating a read-only copy of the state that the file system was in at a specified point in time. That ability has been very useful on other file systems. It'd be nice if HFS Plus supported it. It does not. Another legacy issue is that HFS Plus was not designed for use with Intel processors. So Motorola and PowerPC processors were the order of the day for 90s Macs. And the reason why this matters is that those processors were big endian, and the expected transmission of order of bytes to the processor was set in one specific way. However, Intel processors are little endian, and the expected transmission order of bytes is set in the reverse order from big endian. So the consequence is that all metadata read from HFS Plus volumes on modern Intel Macs must be byte swapped before the processor can use it. So while the performance cost for this behavior is negligible, this does need to be accounted for with HFS Plus, while other more recent file systems simply don't have this issue. So with HFS Plus showing its age and its legacy roots, Apple has made the judgment that continuing to maintain and evolve this 19-year-old file system is no longer tenable. So Apple needs a new file system, and Apple File System, otherwise known as APFS, is being born from that need. So APFS includes a number of features that are not currently available in HFS Plus. The first is that we're upgrading allocation blocks to 64-bit support. So this allows APFS to support over 9 quintillion files on a single APFS volume in place of HFS Plus's 4 billion and change. APFS does support nanosecond timestamp granularity, which improves on HFS Plus's 1 second times granularity. Sparse file support. APFS does support the use of sparse files, which allows APFS to handle empty space in files much more efficiently than HFS Plus can. Snapshot support. APFS does include support for capturing file system snapshots, and those snapshots are also able to be mounted as read-only volumes using the mount APFS command, and we're going to be going back to that in a little bit. Another new capability is what Apple is calling atomic safe save. This works with the nanosecond timestamp granularity to perform save in a single transaction that, from the user's perspective, they either complete successfully or they don't happen at all. So this addresses the problem of a save taking place only partially and potentially causing more issues than just not saving that document at all. Also, extended attribute support. So both APFS and HFS Plus both support extended attributes, but APFS includes native support from it for the get-go, while HFS Plus had to have that capacity retrofitted on. So APFS is structured as shown, with containers being the base storage unit of APFS. So containers are pools of storage, which are conceptually similar to core storage's logical volume groups. In turn, the containers host APFS volumes, which are your actual file systems, the things that mount on your desktop. And each volume then generally maps to a matching namespace, which Apple is defining as meaning sets of files and directories. So while full support for managing APFS is not available at this time, it is possible to create containers, volumes, and namespaces with Discutil. So let's take a look at how this works, and we're going to start off with formatting a disk to use APFS and set up one container. So first thing I'm going to do is run Discutil list, and I've got a drive in here that's completely unformatted. So let me grab that identifier, it's disk 0, and I'm going to go ahead and run Discutil. I'm going to tell it that I want to partition the disk, that my target is dev disk 0. I just want one partition. I'm using GPT for the partition table. I want to use APFS for the formatting, and I want to name that drive APFS, and I want to use 100% of the disk. All right, there we go. And over on the desktop, you should be able to see that we now have a new drive showing up over there called APFS. So to do further work with APFS volumes, you will need to use diskutil's new APFS functions in Sierra and later. So to list APFS objects, including containers and volumes, you would use diskutil APFS list. Now, Apple never ever wants you to forget that in Sierra, APFS is still a work in progress. So anytime you run diskutil APFS commands, you will see this warning. And Apple also recognized that folks would likely want to skip this message if possible, so they did include a command line option for bypassing it. However, this bypass option makes perfectly clear Apple's guidance with regards to storing your data on APFS volumes at this time. So once you're past the APFS warning, the output of diskutil APFS list should look similar to this. So in this case, I've got one APFS container and one APFS volume present on this Mac. So if you have an existing APFS formatted drive and you want to add additional containers to it, you can use the create container command. And this command will also convert an HFS Plus drive to APFS and set up an empty container inside of it. Now this conversion process is destructive. Your HFS Plus volume is reformatted and set up as APFS. So this is something you would do only if you were okay with this drive, not retaining any data. So let's take a look at how this works. I'm going to run diskutil list and get our identifier there. I'm going to run diskutil APFS create container. I'm going to specify that my target is dev disk0s2. All right, that looks okay. I've got my lovely warning. I say yes to it. All right, and went ahead and set up that container. Now I'm going to double check to make sure everything went okay. I run diskutil APFS list. And as you can see, I do have one container set up. However, if you notice, there's nothing appearing on the desktop. That's because your containers are not your file system. Your containers are your pools of storage for APFS. APFS volumes are your file system. Since I don't have an APFS volume set up, I don't have a file system that I can write to yet. So to destroy an existing APFS container and all volumes and namespaces on it, you can use the delete container command. So the APFS volumes are unmounted, and all APFS volumes are deleted along with their parent container. So the APFS container's former physical disk will be reformatted as HFS Plus as part of this process, and you can optionally specify a name for the HFS Plus volume that comes afterwards. And if no name is chosen, the new HFS Plus volume will simply be named untitled. So first thing I'm going to do is run diskutil APFS list. Say yes to get past the warning. All right, and next I'm going to run diskutil APFS. I'm going to say that I want to delete container. And I'm going to specify disk1s2 since that's the container I want to delete. And I'm just going to give the HFS Plus drive that comes afterwards a name. I'm just going to call it new HFS Plus. So go ahead and hit return. Got my lovely warning again. Say yes. It's going to go through. It's going to unmount my APFS volume. It's going to destroy that. It's going to destroy the container. And then it's going to reformat it as a new HFS Plus drive. So to grow a container, you would use the Resize container command. So this allows the option of growing a container's available allocated space when more physical drive space is available. So if you want to have your container resized to fill all available space, you would use the number 0 for the size. So let's take a look at how this works. Let's go ahead and run diskutil list. And I've got an APFS formatted drive. It has 64 gigs of space on it, but I'm only using 42 gigs of space on it. So I want to fix that. So first thing to do is run diskutil APFS list and say yes to the warning because I want to get the identifier of that container. And that's disk1s2. All right, now that I've got that, I'm going to say diskutil APFS, resize container. I'm going to specify that the target is dev disk1s2. And and that I want, by specifying 0, I say I want to grow it to all the space. I say yes to the warning. And then it goes ahead and grows the available the container size from the 42 gigs that it was previously using to now it's using the full 64 gigs available on the drive. So if you have an existing container and you want to add volumes to it, you can use the add volume command. So again, we're running discutil, APFS list, say yes to the warning. All right, and I want to add a volume to the disk1s2 container. So let's go ahead and run discutil, APFS. I'm going to specify add volume. I'm going to specify that the container I want is disk1s2, that I want it formatted as APFS, and that I just want to name the new volume as new APFS. All right, get my lovely warning again, say yes. And now I have a new container, I have a new volume showing up on the desktop called new APFS. So they're both still in the same container. I've just added a new volume to that container. So the Grapefirm is a convenient command, and that combines the functions of the create container and add volume verbs. So it will convert an existing HFS Plus drive to an APFS drive with an empty container, and then it sets up one APFS volume in the container. This is similar in action to when I ran the discutil partition disk command earlier. So let's take a look at how this works. So I'm going to run first discutil list and get the identifier for that HFS Plus drive that I want to convert. And by convert, I mean erase. So we're going to go ahead and run discutil, APFS, create, specify that I want to target dev disk0s2, and I want to name the drive, the volume APFS. So it goes through, sets up a APFS container, sets up a new volume, and let's go ahead and check it out. So we'll run discutil, APFS list, say yes to the warning, and as you can see, we've got a container and we've got a volume. So something to be aware of is that volumes hosted on the same container will all display the same size and available drive space of their parent APFS container. So this behavior is referenced when you list the available APFS drives and you look for the drives listed as space sharing. So even though you've got two volumes showing up on the desktop, they'll each say, I have X gigabytes of free space. The container is the one actually managing those. And we'll see how this works in a little bit. So to illustrate this, I'm going to go ahead and create a 10 gig file on the volume's APFS drive. And it's just an empty 10 gig file, and I'm just going to call it 10 gig file. All right, put in my password for sudo. Goes ahead and creates that 10 gig file on APFS. But next, if we go ahead and take a look at the actual drive space used, even though there's nothing on new APFS, it shows up as having 10 gigs used as well. And the reason is that their parent container knows it has 10 gigs used somewhere. And so it takes it out of both of them. So if you notice, it says one item, 31.93 gigs available, and on the other one it says 0 items, but 31.93 gigs available. It is sharing the space, it's managing at the container level, so that you don't have to worry about it. It is something to keep in mind, though, where available drives will show up as having X amount of space, but maybe they don't both actually have twice the amount of space you think they do. So, because this free space is being managed at the container level, you shouldn't run into an issue where someone tries to save too much data to an APFS volume, but this behavior is something to be aware of when you get SY. Someone's two drives, apparently, they each have X gigabytes of free space each, but you can only save a total of X gigabytes onto both drives. So to help with this issue and to save on disk space overall, Apple is also introducing a new way to handle duplicate files as part of APFS. So I've got an APFS drive, I've got an HFS Plus drive, and both of them are set up with a 10 gig file. So let's go ahead and duplicate those files. So, all right, HFS Plus drive, so the duplication process. Okay, that's going along in a nice clip. Let's go to the APFS drive and duplicate that. And it's done. Oh, this is taking a while. Do you think we have time for more coffee, a break? Anyone need to go to the bathroom? This is going to take forever. Man. So long. Ah, finally, that felt like forever. So, Apple calls this new copy behavior cloning. And they're defining a clone in the context of APFS as being a copy of a file or directory that occupies no additional space for the file data and which can be created instantaneously. And how this works is that when a cloned file is modified, only those modified blocks are being written to disk. And this allows the file system to do two things. One, store multiple revisions of the same document simply by tracking which blocks were saved. And also use less file storage by only writing changes to those copies to disk and then using the original file as a reference for those modifications. So, but then the next question that logically springs to mind is, what if I throw away the original? Well, it's not a big deal. The file system will just reassign those blocks as needed until you've thrown away all copies and the original of the file. As needed, it'll just keep reassigning those blocks around in the file system as needed. It takes care of it transparently. You don't have to worry about any of this. So, as mentioned previously, APFS includes the ability to create snapshots of the APFS file system. And for those not familiar with this, a snapshot is a read-only instance of a file system on a volume. So snapshots can be used to make backups work more efficiently, and they also offer a way to revert changes back to a given point in time. So, in the APFS developer preview included with current releases of Sierra, the APFS snapshot utility can be used to create, delete, and list snapshots. Now, Apple also formerly noted in the APFS documentation, because this notice has now disappeared, that the APFS snapshot utility will be disabled in a future release of macOS. So this tool is going to be superseded by another tool at some point. But for right now, it's what we're going to be using to show how snapshots work. So to create a new snapshot on an APFS volume, you can run the command shown on the screen with root privileges. So let's go ahead and do that. So we're going to go ahead and run sudo APFS snapshot. I'm going to specify -c because we want to create a snapshot. We're going to call it new snapshot. And it's going to be for volumes APFS. All right. Put in our password. We get a different warning about how we shouldn't be using this. But now we've gone ahead and created that snapshot. So to list available snapshots on an APFS volume, you would run the command shown on the screen with root privileges. So let's go ahead and run sudo APFS snapshot. We're going to use -l because we're listing it. And we're going to look for the ones on volumes APFS. All right, put in our password for sudo. Get our warning again, but just past the warning, we now have this listing for new snapshot. So we did make new snapshot. It is stored on the APFS drive. So to delete a snapshot on an APFS volume, you would run the command shown on the screen with root privileges. So let's go ahead and do that. So we're going to go ahead and run sudo APFS snapshot -d. We're going to specify that the snapshot we want to delete is new snapshot, and that it is stored on volumes APFS. All right, put in our password for sudo. There's our warning. And just to make sure that it's gone, let's go ahead and run sudo APFS snapshot -l for volumes APFS. And as you can see, we have a warning again, but this time there is no listing for new snapshot. It has been deleted. Okay, so to mount an existing snapshot as a read-only volume, you will need to use the mount APFS command's -s option. So as part of using the command, you'll also need to specify a directory for the snapshot to mount to. So once a drive is mounted, you should see it appear as a read-only drive in the Finder. And you can also find information about how the snapshot is mounted by using the mount command. Okay, so let's take a look at why this is awesome. So first thing I'm going to do is I'm going to create a 10 gig file on volumes APFS, and I'm going to name it 10 gig file. All right, put in my password. All right, and then created it. Okay, so next let's go ahead and make a snapshot. So APFS snapshot -c. In this case, I'm going to call it 10 gig snap. And I'm going to store it on volumes APFS. All right. And here's where I make the mistake. Oh no, what am I doing? Oh, this is terrible. No, don't do it. No! Wait, I got a snapshot. Okay, so what do? First thing I need to do is I need to make a mount point. So I will be creating a directory out on the desktop. I'm just going to call it desktop recovery. Yep, so there's my recovery directory on the desktop. Okay, remember what you do. Okay, so mount APFS. I'm going to use the -s to indicate that I'm doing a snapshot. It's called 10 gig snap. It's from volumes APFS. Okay, I'm going to trace it. And it needs to mount to desktop recovery. Come on, baby, work. When it mounts, oh, there we go. Am I doomed? Ah, it's 10 gig file back. Ah, so close. So, lastly, because bad things can happen to good drives. If you want to fix a malfunctioning APFS drive, you can run the fsic APFS command with root privileges. To do this, first thing we want to do is run disk-util-list and get the identifier of our APFS drive there, disk1s2. And next we run sudo fsic APFS, and we want to specify that we're targeting dev disk1s2. Put our password, and everything looks like it's fine. So, there are currently several limitations of APFS in Sierra to be aware of. APFS volumes cannot currently be used as a startup disk. Volumes can only currently be case sensitive. This is the reverse from the usual for HFS Plus, where the usual is to be case insensitive. Case sensitivity is the order of the day right now for APFS volumes. Time machine backups are not currently supported. I strongly suspect that introducing snapshot is going to change time machine as we know it. That's just my own speculation. I don't have anything from Apple yet. Also, one thing that is staying behind on HFS Plus is core storage, and that's the foundation for both Fusion drives and FileVault 2. So FileVault 2 is not currently supported on APFS drives. Fusion drives are not currently supported on APFS drives. So with regards to encryption, APFS is going to be using its own native encryption scheme because Apple is building encryption in as a first-class citizen for the file system. For Fusion drives, I simply don't know. It could be that this is the end of the line for the Fusion drive. Who's to say? And because you can never have too much information about a new topic, here are some useful links. Some more useful links. Possibly the most important links you see in this entire presentation. This is how you get it all. So PDF is available with the speaker's notes from the top link, and keynote slides, which include the demo movies, the speaker's notes, the everything, are available from the link at the bottom. So I'm going to leave that up on the screen. And how are we doing on time for questions?
Yeah, we have time.
All right.
Cool. Any questions?
Thanks, Richard, for a walk down memory lane. I'm sure Syracuse was here in spirit. Just a quick question. When I last looked at this, APFS wasn't supporting any sort of checksum or validation to correct itself. Have they popped anything in?
Not as far as I'm aware. They're doing, I want to say they're doing metadata checksumming, but not complete file checksumming. They're just checksumming the metadata.
Okay, so it can change because the lead dev on it said
No.
it was kind of a free-for-all at the moment, and it might arrive or might not.
Yeah, they might not. We'll just have to see.
Hi Rich, thanks. Just wondered if you heard anything about volumes that can span multiple disks, like Fusion Drive or whatever, or RAID as well?
Yes. I did ask about this at the last WWDC, and the answer is that if you want to set up a APFS volume that spans multiple drives, you will need to do that on a RAID. And they mentioned using basically a software RAID to do it, or a hardware RAID, and of course with the hardware RAID, it just looks like one big drive. But natively, right now, APFS does not support spanning multiple drives.
Okay, thanks.
Thanks. I'm just wondering if we're now all looking forward to a bright future of supporting users where we get the call saying, hey, my disk is full, and we say, oh, right, try deleting some files. I've deleted some files, it's still full. And suddenly we have to go hunting around for snapshots or other copies of these files that could be taking up the space. It feels potentially confusing. But do we trust that Apple will put some kind of Apple-y UI on it that will make everything okay?
Currently, they haven't. I mean, as you saw from my demonstrations, everything was command line. I strongly suspect they will, but I have not seen that as of yet. And yeah, there will be, I mean, this is a file system that is going to behave differently than how HFS Plus has behaved. So there might be some confusion, there might be some people going, I don't understand why this is doing the thing that it's doing. But as with all things, eventually we'll figure it out.
Thanks. I don't think you mentioned it, but I was reading from one of the developer conference presentations that you will be able to upgrade an HFS Plus volume to APFS as well.
Yes, and that is supposed to be a seamless and transparent transition. I have tried to make that seamless and transparent transition work. I have not currently succeeded. I was actually hoping that 10.12.4 would be out sooner. I got a little further with testing that, but unfortunately, since that's still under NDA, I can't really discuss that.
Thank you.
Rich, I know that APFS is supposed to support copy on write. Are you able to elaborate any more on that at all?
I'm sorry, could you repeat the question?
Sorry, I know APFS is supposed to be supporting copy on write. Do you know anything more about that? Are you able to elaborate on it at all?
So copy on, I think is that atomic save or is that something else?
Yeah, I think they're calling it crash protection, but I'm not sure if it's one and the same thing.
Yes, that is atomic save, and what it is that's the capability with the new nanosecond timestamp granularity to track whether or not that write to the file system is succeeding or not. And if it looks like it's not succeeding, the file system is just rejecting it.
Thank you.
Well, the obvious question might be, is this Apple's way of implementing ZFS?
Implementing, I'm sorry, I didn't catch that last.
ZFS?
That is an excellent question. This is not exactly ZFS. This is similar to how ZFS operates, but this is not ZFS. Last I heard about ZFS, that got bogged down in licensing issues, not technical issues. So I don't think we'll be seeing Apple bring ZFS to the file system anytime soon. This is close in terms of capability and functionality, but it is not ZFS.
Could you mention to us how you feel that APFS could change imaging?
Imaging is dead. Or rather, let me amend that. It will be dead real soonish, because this is something that Apple has been saying to a number of folks, that with APFS you're not going to be able to do the ASR imaging like you've been up to this point. What replaces it? I don't know. My own best guess at this point is that either Apple's going to say they're going to leverage snapshotting to get you back to kind of that clean, unconfigured state that you were before, much like you can do on iOS by tapping the erase all content and settings button. Or they'll just be like, you need to boot to recovery or internet recovery and reinstall. We simply just have to see. But in terms of ASR block copy imaging, I don't think that's going to work with APFS.
Extending on a little bit from that question, the current iOS betas are look to have implemented with that in mind, what would be your sort of best educated guess as to the timelines that we'd be thinking about regarding macOS?
With regards to macOS, I would be very, very surprised if we do not see this in whatever the next version of macOS is. I don't necessarily see boot support coming yet to Sierra. That'll be one of those things that if it does come, it'll come around about the time they're releasing the new operating system. Right now there is no boot support. I wouldn't be surprised if boot support for Sierra simply never arrives. But macOS next, I would be surprised if we don't see it.
And do you think it will be the default?
That is a good question. I don't know. It may be the default. It may be that Apple says, okay, we're gonna give it another year for people to figure this out and keep using HFS Plus as the default. We'll simply have to see. The fact that they're already moving ahead with iOS, using APFS on iOS, and once again, this is using that seamless conversion that they had discussed at last WWDC. I think that Apple will move aggressively on this, but we will simply have to see. This year's WWDC is going to be very interesting.
No, it was. No, I'm joking. It was just to say actually what they were saying about risk of data loss. I was naughty and was just playing with APFS just now and had 2 kernel panics in the space of 5 minutes. So the warnings are true.
Yes. Yeah, don't stick anything you care about right now on APFS. Use it for testing, but don't put anything on it that it affects your livelihood, or anything you care about.
So we're all done with the questions?
And the next question is going to be all the way in the back, right?
Just a quick one. Will going to APFS affect app developers at all in how they create their apps, or especially with some apps that do a lot of reading and writing of data to local disks?
Excellent question. I will say that any apps that don't deal with a case-sensitive volume will probably have issues. Developers that work with the file system, they will definitely have to make changes to accommodate APFS. But if you're just running an application and just building in the standard, save dialogues, to just save things wherever, I don't think that's going to change anything because you're interacting with a higher level API than the file system. So the answer is a qualified no. I don't think developers will be too heavily affected by this.
And sorry, second question. Will it affect recovering deleted files from drives? Will it make that any easier or any harder?
To be seen. I would say right now APFS will definitely lose files more easily than HFS Plus does, but that's because it's a work in progress. With snapshotting, since you can get those, since it can save that metadata, save that file system in the state that it was, I think we'll actually see it a little better with getting stuff back that got deleted. But in terms of, like if you ship the drive off to drive savers, is that job going to get any easier? I simply have no idea.